Good everyone, you are welcome to class. If today is your first time of joining this platform, you are wholeheartedly welcome to this great family of scholars. And for my returning subscribers and followers, thank you for always coming back. On this platform, I teach mathematics and physics. But for today, I'll be teaching a topic in physics. Without much ado, let's jump right into what we have for today. But before we start, I want to leave you with this statement that says, what you don't know is more than you. As a result, stay put and watch this video from the beginning to the end so that you can know what you never knew before as far as physics is concerned. Quantities in physics can either be classified into scalars or vectors. These physical quantities are used differently in numerical calculations. At the end of this class, you should be able to explain the concepts of scalars and the concepts of vectors. You should also be able to distinguish between scalars and vectors. You should also be able to represent a vector. Now let's talk about the concept of scalars. Many measurable physical quantities we encounter in the study of physics today have only numerical values. That means they have only numbers. Such quantities can be completely described if only their magnitude or size are known. Examples of such quantities are your length, which you can also call distance, speed, temperature, mass, volume, density, time, and energy. These quantities are called scalars. Now the question now is, what are scalars, or we call it scalar quantities? Scalars or scalar quantities are quantities that have only magnitude or numerical value but has no direction. Now to buttress my point on what I mean by scalars or scalar quantities, I will use these first three examples to explain. The first one is length, which you can also call distance. Now if you say a distance of 50 kilometers, what does that mean? A distance of 50 kilometers can either be measured in a straight path or in a circular path, since no direction was specified. So it means that with just this number, or you call it magnitude, or you call it size, or you call it numerical value, you can describe this scalar quantity called what? Distance. So also, let's use speed too. If you say a speed of 50 kilometers per hour, what does that mean? It means that a speed of 50 kilometers per hour can either be measured in a straight path or in a circular path, since no direction was specified. So that means with this 50 kilometers per hour, we can describe this scalar quantity called what? Speed. Also, temperature. Temperature of 100 degrees is just a number in a scale, since it has no directional property. So any quantity that can be described by only numbers or numerical value or magnitude, as you can see, we call these quantities scalar quantities. Another thing you must know about scalars or scalar quantities is that scalar quantities are added by ordinary arithmetic method. What does that mean? It means that scalar quantities are added in normal way you add numbers. Like 2 plus 2 will give you what? 4. 3 plus 3 will give you what? 6. So just like that, that's how they add what? Scalars. Let's take, for example, addition of volume. Volume, as we know here, is an example of what? Scalar. So let's say addition of volume, let's say 5 centimeter cube and let's say 2 centimeter cube will give us what? Will give us 7 centimeter cube. So as you can see, the addition is just the normal way you add numbers. But when it comes to vectors, I will look at later, you see that the addition of vectors is far tedious and different from the way scalars are added. So from what we have said so far, you can be asked to define scalars or scalar quantity. So when you are asked that kind of question, you simply say scalars or scalar quantities are quantities that have only magnitude but no direction. And if you are asked to give examples of scalars, you can as well what? List these what? Examples. Now let's talk about the concept of vectors. Many other measurable physical quantities have both magnitude or numerical value and direction as well. Such quantities cannot be completely described unless you know both their magnitude and direction. Examples of such quantities are displacement, velocity, acceleration, weight, force, momentum, electric field. These quantities are called vectors or vector quantities. What then are vector quantities? If you are asked to define vector quantities or vectors, how will you define it? You see that word vector quantities or vectors are quantities that have both magnitude and direction. To buttress my point on what vectors are, I will use the first two examples of vectors, which is displacement and velocity. What is displacement? Displacement is distance in a specified direction. Now let's take a look at this first statement. A bird flies a distance of 100 kilometers in a northeasterly direction. This statement describes the vector quantity called displacement. Now, why did we say it describes the vector quantity called displacement? Because it has distance. It has distance which is measured in a what? A specified direction. So with this distance that is 100 kilometers and this direction, northeasterly direction, this statement completely describes what? The vector quantity called displacement. Now let's use velocity to buttress our point on what vectors are too. So let's look at this second statement. A car travels due west at 90 kilometers per hour. This statement also describes a vector quantity, but this time around the vector quantity it describes is what? Velocity. The question is, what is velocity? Velocity is speed in a specified direction. So looking at this statement, a car travels due west at 90 kilometers per hour. You may be wondering, what makes this statement to describe the vector quantity called velocity, where you cannot find anything like speed here? It is true that you cannot find speed here, unlike that of displacement where there's distance here. Now, you cannot find speed here does not mean that there's no speed here. Now, how do we know the speed? Since the speed was not spelled out here, we know the speed as a result of the units against beside this what beside this number 90 kilometer per hour. Kilometer per hour is a unit, is one of the units used to measure speed. So that's why as a physics student you must be conversant with units used in physics. So with this kilometer per hour, I already know that this is our what speed in this statement. So since there's a scalar quantity called speed here, and there's also a direction. So since there's speed here, and we also have direction. The direction is what? Due west. So with this speed and this direction in this statement describes what? The vector quantity called velocity. Having said that, another thing you must know about another thing you must know about vectors is that vectors are added by geometric methods, unlike that of scalars that are added by ordinary arithmetic method. For vectors, they are added by geometric method, and the addition of vectors is much more complicated compared to the addition of what? Scalars. Despite the fact that it's more complicated, does not mean it is difficult to understand. So what is geometry? Geometry simply means what? The relationship between lines and angles. So it is the relationship between lines and angle that is what? Geometry. So when we say vectors are added by geometric method, it means that angles and lines will be involved in the addition of what? Vectors. So in my next video, we'll be looking at the addition of vectors. So do not miss that video. It will be very important for you. Now, from what we have said so far, you can be asked to differentiate between scalars and vectors. What will you say? You should say that what? Scalars are quantities that have only magnitude but no direction, while vectors are quantities that have both magnitude and direction. You can as well say that scalars are added by ordinary arithmetic method, while vectors are added by geometric method. Now let's talk about vector representation. How do we represent a vector? Since we know that a vector must have both magnitude and direction, then we can represent a vector by a straight line carrying an arrow head like this, where the length of this line represents the magnitude of the vector, and the arrowhead represents the direction of the vector. Mind you, we said what? To represent a vector, we said to represent a vector, you represent a vector by a straight line with what? An arrowhead. Mind you, this straight line can be vertical straight line. It can also be horizontal straight line with an arrowhead. It can also be slant straight line with an arrowhead. These are the three ways we can represent a vector. But one thing that is peculiar with the three of them is that they have what? A straight line with an arrowhead. With this, we have come to the end of today's class. If this video has been helpful, please give it a thumbs up. Subscribe and follow me on all my social media platforms. Also comment if there's something you feel I have not done well. Write it in the comment section so that I will know in order for me to improve next time. If there's something you feel I've done very well, also write it in the comment section so that I can also improve on it and do it better next time. Above all, please share this video to as many people as possible so that you can get this knowledge. Till I see you again next time, keep living life. Bye for now.